This session is for OCR FP1. The topic is matrices, and the question we're going to be looking at is June 2010, question 9. So let's just start by reading through the question. So we're given a matrix, capital A, a 3 by 3 matrix involving the little letter A, an unknown letter number. And in part 1 we're asked to find, in terms of this A, the determinant of the matrix. And then in part 2 we're given 3 simultaneous equations involving again this little unknown A. And for each of these following values of A, we've got to determine whether the equations are consistent or inconsistent. And if the equations are consistent, we've got to determine whether or not there is a unique solution. And the 3 values of A we've got are there, 0, 1 and 2. So let's start by looking at part 1, where we're asked to find the determinant of A. Now, in order to find the determinant of a matrix, then we're going to need to make sure we remember about the sign attached to minus. And so I'm just going to write that matrix of signs up there. So I'm going to expand by the first row. So if I do that, then I'm going to take the first A and I'm going to multiply it by its cofactor. Now its cofactor is going to have a positive sign because it's the entry in the first row and the first column, which is positive. So, and then the minor is given by the determinant of this 2 by 2 matrix here. So in a sense you're crossing out the first row and the first column and you're finding the determinant of this matrix. So it's A times 1 minus 2 times 2. So that's A minus 4. And then for the next one, so the second entry in that row will have a minus sign attached to it. So that is going to be minus A. So this time we're crossing out the first row and the middle column, and we're finding the determinant of the 2 by 2 matrix, which will be 0 times 1, which is nothing, minus 2 times 1. And then the third entry is a minus 1. It has a plus sign attached to it. Again, we can just check that from our matrix of signs, and then it's going to be minus 1 times, and again this time you're crossing out the first row and the third column, so it's 0 times 2, which is nothing, minus A times 1. And we should just simplify that and we'll get an A squared minus 4A. We have a plus 2A there, and we have a plus A at the end there. So in fact we seem to have A squared minus A, and that is our determinant. Now you could have expanded by any row or any column, and many people will say, well, we maybe would have been quicker to expand by the first column because one of the entries there is 0, so you'd have only had 2 terms to work out. But as long as you realise it doesn't matter whether you expand by whichever row or column. So there were 3 marks there for finding the determinant. So the first mark was for finding using a sort of correct method. So you got a method mark for trying to expand by a row or column. You also got another method mark for getting any of the 2 by 2 matrices sorted, and then you got an accuracy mark at the end here. So 3 marks in total. So let's have a look at the second part then. So we've got these simultaneous equations, and for each of these, as I say, we've got to decide now with A equals 0 is the first one. And then if you remember, part B is A equals 1 and then A equals 2. So let's consider A equals 0. So as long as you can see that these simultaneous equations here are the same or can be represented in terms of matrices, the matrices of coefficients is just our matrix A, capital A, that we had in part 1. So what we need to do is put in A equals 0 into our determinant. Then the determinant of A will be A squared minus A, if you remember, equals 0 when A equals 0. Now if the determinant is equal to 0, then we can't use matrix methods. There isn't going to be a unique solution. So we can't use the inverse of the matrix. It won't exist if the determinant is equal to 0. So what we actually have to do is let's just put A equals to 0 into these equations, and the first equation will become minus z equals minus 1. The second equation will become 2z equals 0. So if you look at that, then we have two equations immediately which are what we refer to as inconsistent, because the first one tells us that z equals 1, the second one tells us that z equals 0. Well, we can't have z being equal to two different things. So we say that these are inconsistent. And that means there's going to be no solution. So when A equals 0, there is no solution. Let's see what happens when A equals 1. Now when A equals 1, the determinant, remember again, was A squared minus A. And again, that will be equal to 0 when A equals 1. So again, we cannot use matrix methods because there is not going to be a unique solution. So if we put A equal to 1 into these equations, then we're going to get x plus y minus z equals minus 1. We'll get y plus 2z equals 2, and x plus 2y plus z equals 1. So all I've done is substitute my value of A equals 1 into these equations. So if I call those 1, 2 and 3, then the second equation just connects y and z. So let's use the first and third equation to eliminate x. So that's what I'm going to do. So I'm going to take the third equation and subtract the first equation. And if you'll see, if I do that, then the x's disappear and you end up with y plus 2z is equal to 2. But of course the second equation also said that y plus 2z was equal to 2. So that means we have consistency. So they are consistent. You've got two equations. So you have this idea of the repeated equation here. So consistent, but not a unique solution. So it's a non-unique solution. In fact, it's going to be an infinite set of solutions. So hopefully that's okay. And if we just look at the last part now, this part here we're doing where A equals 2. So again, remember that the determinant of our matrix we found to be A squared minus A. And when A equals 2, that means that the determinant is going to be, well, it's going to be 2 squared 4 minus 2, so the determinant of A is going to be equal to 2. So the important thing is that it's not equal to 0. And that means we will have a unique solution. So going through that, and just again, in the first part when a equals 0, we had no solution. A equals 1, we had a solution, but it was not a unique solution. And then in part C, we did find that there was a unique solution. So if we just have a look at the marks for this bit, just going back to part A, again 2 marks for each of these sections. So in that first one, you got a method mark for getting these equations here, and you also then got an accuracy mark for saying that they were inconsistent and no solution. Similar sort of thing in part B. You got a method mark here for showing that there was a sort of repeated solution, and you got an accuracy mark for saying that they were consistent or a non-unique solution. And then in part C, you got a B mark, they call it, just for writing down the fact that the determinant was not 0, and therefore there was a unique solution. So 6 marks in total for that part. And then remember, there were 3 marks for part 1, so 9 marks in total for the question. So don't forget that if you want to do more revision and do further questions on this topic or any other topic, then if you go to the website, then there are plenty of revision videos and the links will be there.